Okay, our next question is let A and B be set such that A intersection B, sorry, A intersection X equals B intersection X, that is equals to phi, and A union X equals B union X for some set X. Show that A equals to B. Now here also we will use the same concept that the two sets are equal when they are the subset of each other. So now, solution. Let's start with what is given to us is A union X. A union X equals B union X. Now A union X equals B union X. Now what we is that we will take intersection A on both the sides. Taking intersection A on both the sides. Now A intersection A union X equals A intersection B union X. Left hand side, right hand side, LHS, RHS. Now the LHS. Now LHS, as we know, A union X. Whatever is the element of combining these two, intersection A will give you A only. So this LHS becomes A. This is equals to, now applying distributive law. So this will be A intersection B union A intersection X. So again by applying distributive law, A intersection B union A intersection X. Now what is A intersection X? Now if you see the question, A intersection X equals phi. So write here phi. So combining this, A equals to A intersection B union phi. Now union phi means A intersection B only. So basically what is A? A equals A intersection B. So this A equals A intersection B. Now this implies that if A intersection B is giving you A, that means A is the subset of B. Now again, starting with the same thing, like starting from here, taking A union X equals B union X. Now see, now this is an important step because we know that as A union X equals B union X, so we can interchange this, like we can write this as B union X equals A union X. This will not make any change. So B union X equals A union X. Now taking intersection B on both sides. Now B intersection B union X equals B intersection A union X. Now again B union X intersection B will give us B only. This is common, and yeah, and by the distributive law, this will be B intersection A union B intersection X. Now again we know that B intersection X is phi. So this B equals B intersection A, union phi. So this implies B equals B intersection A. Now again by this statement, B intersection A is B, so this implies B is the subset of A. Now again from 1 and 2, again from 1 and 2, A is a subset of B, B is a subset of C. A is a subset of B, B is a subset of A, implies that A equals B. Hence proved. Hence we have shown that A equals B. So our next question is, find set ABC says that A intersection B, B intersection C and A intersection C are non-empty sets. Means they have something in common. And A intersection B intersection C is fine. So here also we will prove it by taking example, but we will take the a very simple examples. Like we can take A as 3, 4. Okay, let it be any element. B we have to take as 4, 5. Now I have taken 4, 5. See, this you can take any element, 1, 2, 3, 4, 5 is anything. I have taken 3, 4. B has 4, 5 because A intersection B are non-empty sets. So there should be some common between A and B. Okay. Now C, we have to include like 3. Now why this? Because see, B intersection C is a non-empty set. So there something should be common. And similarly A intersection C, something should be common. Okay. Now we know that what is A intersection B is A intersection B 4. B intersection C 5. A intersection C 3. But if we take A intersection B intersection C, A, B, C, there is nothing common. Proved. Next question. In a survey of 425 students in a school, it was found that 115 drink apple juice, 115 drink apple juice, 160 drink orange juice, and 80 drink both apple as well as orange juice. How many drink neither apple nor orange juice? So starting with the solution, C. We can take U as the universal set is the total number of students. Now that is the total number of students, and take A is a set who drink, number of student who drink apple juice, and B is a number of students who drink orange juice. Now according to the question, we can write them as N of U is how much? Is 425. N of A is 115. N of B is 160. And N of A intersection B is 80. Okay. So by using the formula, as you know, the formula that is used is we can find the total number of students who drink apple as well as orange juice. So that will be N of A union B. Now according to the formula, this is NA plus NB minus N of A intersection B. So this is 115 plus 160 minus 80. Total is 195. So this is the total. N of A plus NB minus N of A intersection B. So means the total number of students who drink both apple and or orange juice is 195. Now to find how many drink neither apple nor orange juice, so we can take the total minus the minus the number of students who drink both like apple and orange juice. If you minus them, we will get the total number of students who neither drink apple nor orange juice. So basically, the total number of students who drink neither apple nor orange juice is represented as A dash intersection B dash. Okay. So now according to De Morgan's law, this is A union B whole dash. Now A union B whole dash means what? You find A union B, remove it from the total. So means 425 minus 195. This will give you 230. So 230 are the number of people who neither drink apple nor orange juice. So this is basically a simple concept. See, what's first of all we have done is that we have find the total number of students who drink both apple and orange juice. And then from the total, you minus them, you will get the number of students who drink neither apple nor orange juice. So the next question is, there are 260 persons with a skin disorder. If 150 had been exposed to the chemical A, 74 to the chemical B, 36 to both chemicals A and B, then find the number of persons exposed to. First part is chemical A but not chemical B, chemical B but not chemical A, chemical A or chemical B. So first of all, let again the same thing, let U, this solution, U be the set of all persons. This represents all persons. Okay. Now A represents with the chemical the persons who are exposed to chemical A, and B who is exposed to chemical B. So by the given information, we have N of U is 260, N of A is how much? 150, N of B 74, N of A intersection B is 36. So N of U is 260, N of A is 150, N of B is 74, N of A intersection B is 36. Now the question 1 is chemical A but not chemical B. And if you remember the diagram like this represents universal set, this is set A, this is set B, this one is A minus B, this is A intersection B, and this is B minus A. This again I have already explained in the previous videos of sets. So the first part is, our first part is chemical A but not chemical B. So basically chemical A but not chemical B, the first part is we have to find A minus B, N of A minus B. So now from the diagram it is clear that N of A minus B plus N of A intersection B is equal to what? Is equal to NA. Now we can substitute the values. N of A intersection B, just a second. N of A intersection B is 36. N of A is 150. So N of A minus B plus 36 equals 150. So N of A minus B equals 150 minus 36. This is equals to 114. So the first part is chemical A but not chemical B is 114. Second part, chemical B but not chemical A. So this is basically N of B minus A. B minus A. Again from the diagram, as you can see from here, N of B minus A plus N of A intersection B equals NB. Now substituting the values in this, we have to find N of B minus A. N of A intersection B is 36 and B is 74. N of B is 74. So substituting the values, N of B minus A plus N of A intersection B, which is 36, plus 36 equals N of B 74. 74. So N of B minus A equals 74 minus 36. So this is equals to 38. So second part is chemical B but not chemical A is 38. Now chemical A or chemical B means A union B. So for that we have already learned the formula. Sorry, this is second part, this is third. Like N of A union B is equals to NA plus NB minus N of A intersection B. So substituting the values, what is NA? 150. What is NB? 74. What is N of A intersection B? 36. So if you do this calculation, 150 plus 74 minus 36, that is equals to 188. So chemical A or chemical B is 188. Yeah. A class has 175 students. The following description gives the number of students studying in one or more subjects in this class. See, mathematics is 100, physics is 70, chemistry is 46, mathematics and physics 30, mathematics and chemistry 28, physics and chemistry 23, mathematics, physics and chemistry 18. Now, how many students are enrolled in mathematics alone, physics alone, chemistry alone? Number of students who have not offered any of these subjects. So see, actually in this example we will be following an easy approach. Instead of using that A union B union C formulas, we will be using an easy approach in which we will consider as ABCD. Now just take an example. Okay, now the solution starts. See, they have taken mathematics, physics and chemistry. So let this denotes mathematics, physics and chemistry. Okay, this is M, P, C. They know the set of students enrolled in mathematics, physics and chemistry, as you can see in the figure. Now, these values I will be writing in ABCD, and then we will make an equation and then we will solve for those. Like suppose here we write A, this is B, this is C, D, E, F and G. As you know, they have their usual meaning. Like A represents which have number of students which have only maths. B represents which have both maths and physics. E will represent the student having only physics. D will represent students having both maths and chemistry. F will represent the students having both physics and chemistry. G only chemistry, and C the number of students who have all three, mathematics, physics and chemistry. So by the following data. Now it is given that mathematics is 100. Mathematics means including all A plus B plus C plus D. is 100. So we are writing A plus B plus C plus D is 100. Next is physics is 70. So B plus C plus E plus F is 70. Chemistry is 46. Chemistry is 46. So C plus D plus F plus G is 46. Mathematics and chemistry 28. Mathematics and chemistry means C plus D. C plus D is 28. Oh, sorry. First word, mathematics and physics. Okay. Mathematics and physics is 30. Mathematics and physics is B plus C. B plus C is 30. Sorry, I missed that. But I have written C plus D. Second part is then mathematics and chemistry. Physics and chemistry 23. Physics and chemistry 23. C plus F 23. And mathematics, physics and chemistry is 18. Means C is how much? C is how much? 18. With all the subjects. Not taking this, we can solve this equation. Now if C is 18, we can find F. If C is 18, C, what will be F? F will be 23 minus 18, which is 5. Now we have F. We can find B also. B will be, B plus C is 30. So B will be 30 minus 18. So B will be 12. Similarly D. D is 28 minus 18. So D will be 10. Okay. Now we have C, D and F. We can find G. So G is basically 46 minus 18 plus 5 plus 10. What will be G? G will be 13. Similarly E. E, we know B, we know C, we know F. So E will be 70 minus, then bracket 12 plus 18 plus 5. So E will give you 35. Then what is left? What is left is A. A you will get 100 minus B plus C plus D. So 100 minus 12 plus 18 plus 10. A comes out to be 60. Now the question. How many students are enrolled in mathematics alone, physics alone, and chemistry alone? So maths is what? Mathematics alone is A, which is 60. Physics alone, which is E, which is 35. Chemistry alone is G, which is 13. Okay. Number of students who have not offered any of these subjects. So basically you take the sum of all this, A, B, C, D, E, F, G, and minus it with the total number of students, which is 175. So number of students who have not offered any of these subjects will be 175 minus A plus B plus C plus D plus E plus F plus G, which is 175 minus 60 plus 12 plus 18 plus 10 plus 35 plus 5 plus 13.